Hi, folks. Let's just get this fired up here. Okay, here we are. We're live from Victoria, BC. Woohoo! Oh, there are already 14 people here. Thank you for showing up. 15 now. Okay, we're going to get started in just a moment here. We'll see if anybody else comes and joins the party. Oh, we went from 15 to 9. Oh, well. That's the way it goes. All right, it's going to give one more minute, and then we'll get this party started. Hope you're having fun out in the snow. Got the toboggans ready, waxed up, and dusted off the snowshoes, cross-country skis, got the pants and the parkas out of the storage. Becky Subiron said, will this recording be provided to us to review at another time? Yes, it is being recorded, and as long as you have this URL, you'll be able to find it and watch it whenever you like. So, okay, it's 6:32, and we have about 1/3 of the people who've registered are now here, so we'll get started. Thank you for showing up. As I said, with the tremendous blizzard outside, I wasn't sure how many people were going to be able to attend. Um, and I apologize in advance. I have a bit of a cold. Marcia told me I should go back 2 meters from the camera, but I told her I wouldn't be able to read anything if I did. Hi, Phil. Thanks for being here. You're welcome. And I'll do my best not to sneeze on you. And well, away we go. So the 5 W's of computer backups. This is not just, hey, Tim, um, thanks for showing up. This is not just about photography, but basically about anything digital. And the 5 W's, as you know, are who, what, where, when, and why. And then there's how, which doesn't rate a W, but it's certainly in there. As I mentioned in the preview, I'm definitely not the most qualified person in this group to be giving this talk, but this is what you get. So we'll make a stab at it and see how we go. Okay. Um, so before we get started, get over here on the right screen. First, a little history. And this may not be important to you, but I think it's important to see where we've been in order to see where we are. And we'll get into more of that as we go along. The first computer as we know it was the IBM 305 RAMAC in 1956. It was about the size of your average living room. Um, this is well, this is part of it. You see these two cabinets. There's one here and there's one here. Each one of these cabinets is an IBM 350 hard drive. Each one of these cabinets had a capacity of 5 MB. Yeah, with an M. And each one of these cabinets had a price tag of $50,000. Now, in 1956, the average price of a house in the United States was $10,000. So for the price of one of these cabinets, you could buy 10 houses. Yeah. Uh, we move along a little bit. In 1980, they introduced the first 1 GB hard drive. Apparently, I can't confirm the legitimacy of this, but apparently Bill Gates once said 40 megabytes of hard drive space is all you'll ever need, which only goes to show that the greats can be wrong if that is in fact true. And um, so in 1980 we had the first 1 gigabyte hard drive. It was 550 pounds, not quite as big as one of these cabinets, but about the size of 2 refrigerators, and it would cost you $40,000. So we fast forward another 40 years into 2021, and this, hold this up to the screen so that you can see it. This is what 1 terabyte looks like in 2021. Um, this is a micro SD card. This is actually a 256 gigabyte drive, but you can get these up to 1 terabyte for around $250. Okay, um, so this is thousands of times the capacity of the original RAMAC 350 drive, and it's something that it fits between your finger and your thumb. It's about and a 1 terabyte micro SD card is going to cost you about $250. Now, I will say that if you really want to, you can go on someplace like Amazon and buy a 1 terabyte drive for about $30. And if you're foolish enough to do that, well, good luck to you, because I certainly would not. Um, okay. So back in these days, if you've watched old black and white films, you'll also have seen cabinets with huge tape drives, reel-to-reel tapes. Actually, I owned a PC, a desktop computer back in the mid 90s that had a tape drive built into it. It was much smaller. It was about about that big and about that thick. But that was my backup system for that computer. Um, and it worked well for what it did. Um, but in addition to tape drives and hard drives, in the early days, of course, we had floppy drives. The first floppy drives were 8 inches square, and they had a capacity of, if I remember correctly, 360 kilobytes. And then they got smaller. We got down to the 5 and a quarter inch drives, same capacity, but you know, about a little over 1/4 of the space. Um, and then from there, we got the 3.5 inch drives, and they started out at 360K, and then we got double density drives that were 720K, and then the double-sided double density drives, and all of a sudden we were up to 1.1 megabytes. That was huge. Um, and but just, I'm not going to list everything I can remember, but just to give you an idea, we had Bernoulli drives, which were a type of hard drive. We've had zip drives, jazz drives, RAV drives, hard drives. Uh, in the entertainment world, we've had uh, LPs, 8-track tapes, cassette tapes, VHS, beta, laser discs. Uh, in terms of hard drives, we've had IDE drives, SCSI drives, SCSI drives, SATA drives, which are the standard nowadays. Um, after and in conjunction with the other things like zip drives and floppy drives, we had CDs show up around 1980, I think. And then a CD had a capacity of about 780 megabytes. Then we had DVDs, which actually got us to 3.7 gigabytes, I think, was what the capacity of a DVD was. And then we also had, in the entertainment world, we had HD DVD and Blu-ray, and Blu-ray came out on top of that. Blu-rays started off at 25 gigabytes, and I think they got up to a capacity of 100 gigabytes. Um, in terms of displays and monitors, we started off with VGA connectors, then we had HDMI connectors, and of course, if you've got an HDMI connector, you needed a mini HDMI. We also have DisplayPort, a mini DisplayPort. If you have an 8K TV, by the way, at 60 kilohertz, you're going to need two DisplayPort 1.4 connectors in order to drive the thing. Um, On the back of our computers, we had parallel ports for printers, serial ports for other devices, PS2 ports for your mouse and your keyboard. We had game ports to connect to game controllers and things like that. And then all those were wiped out, and we had USB 1. USB stands for Universal Serial Bus, in case you're wondering. But we had USB 1 and then 2 and then 3, 3.1, 3.2. Um, and they had varying increases in speed and power. The standard USB connector, that I'm sure you're all aware, looks something like that. This is a USB-A connector, and but in addition to that, we had mini USB, and if you ended up with a cell phone, we had micro USB, which looks like that end of this cable. We had USB-B, which was for the back end of your printer. That's how you connected your printer to your computer. And we had micro USB B, which looks like this one. And we also had, nowadays, we moved into the world of USB C, which looks like that. Um, and it's actually the same connector as a Thunderbolt. Um, if you're in the Mac world, of course, you had Lightning and things like that. Um, for connecting to the network, we had Ethernet cables, and then we got Wi-Fi, which incidentally doesn't actually stand for anything. Um, and can we get speaker onto main part of screen? Yes, we can. Just give me a second here, and let's see what we can do. Of course, Diane, this means you have to look at me. Um, but yeah, it's none of the things I've been talking to you about are any real importance. But I just wanted to highlight a couple of things. I talked about Wi-Fi. We had um, yeah, Wi-Fi A, Wi-Fi B, Wi-Fi G, Wi-Fi N. We now we have Bluetooth and NFC. You know, for your camera, we had micro hard drives and compact flash cards and memory sticks, and then we got secure digital cards and micro secure digital cards. Now we're at XD cards and CF Express cards are coming out. The general theme in all of this is that things are getting faster. And hi, Todd. Yeah, it's scary to me when I go to the Royal BC Museum and they have a section in there of things from the last millennium, and I'm going, hey, I still own some of those things. Anyway, yeah, the general rule is that things are getting bigger and faster, but also that technology has changed considerably and will continue to change considerably. This is an Android smartphone, and it's important to realize that 15 years ago, this did not exist. Um, I still had one of the. I remember I had one of the old bag phones. They were about this big, and it was pretty cool at the time. If you were in a part of the world that actually had cellular tower. Of course, with all of these different cables, connectors, drives, and things, we need adapters. This thing here, for example, has a USB-A connector on one end and a USB-C connector on the other end. Uh, my current computer is a Dell laptop. It has two USB-C ports and two Thunderbolt ports, and that's it. Um, and so the reason I'm mentioning all this is that when we talk about backups, one of the things we're thinking about is archive and long-term. And it's important to realize that technology changes, it changes quickly, and it very rarely goes back. And it's not just hardware either, it's software as well. Back, if you go back 30 years or so, and you had some 35 millimeter slides that you wanted to get scanned, um, you could take them into Kodak and they would create JPEGs for you. Or if you wanted better quality, they would create PCD files. There's very little software available today that will read a PCD file. There's still some, but not many. And so if you have an old CD with PCD files on it, and yes, I do, um, then um, you have to be aware of things like that. Every camera company has its own proprietary RAW format, and not only that, they seem to change formats with every new camera that they bring out, because one NEF file should not be able to the same as any other NEF file. Now some of that is required, but these are just things to think about in terms of long-term storage. So as far as my own experience with computers, when I was in high school, grade 11 actually, I signed up for a computer fundamentals course. It was canceled due to lack of interest. So forgive me. As I mentioned at the beginning, I have a bit of a cold, so I'll try not to sneeze on you. And I'm staying back as far from the camera as I can, so you should be fine. Um, when I went to college, my first computer course there consisted of taking paper cards, and we had to mark the cards. We didn't actually have punch cards; we had to mark them by hand, and then we would take our stack of cards over to a little box in the reception office and put them in that box, and then somebody would courier them over to the university in the closest city, and a computer technician there would run the cards through their computer and give you a printout the next day, and then you had to go through and debug your code and fill out new cards and put them in the box. So anyway, and but we're here to talk about backups. So um, this is just an example of how much technology has changed. And I remember when I was studying geographic information systems in the 80s, one of my professors told us that he was in a classroom where they handed out a stack of pages to everybody to type in. And they all stood back, and everybody sitting in front of their keyboards, probably in a dumb terminal connected to a mainframe. But anyway, everybody's banging away, and they waited until they got about half through, three-quarters of the way through what they were doing, and then they said, "Okay, cut the power," which they did, and everybody's work vanished. And then the teacher turned to everybody in the room and said, "Okay, let's talk about backups." And I remember being in the computer lab, the first computer lab at the college I went to, and it was quite common to hear students saying, "I spent 3 hours or 6 hours or whatever working on that, and then it's all gone." And you know, whose fault is that? Well, there's only one answer to that. It's yours. Um, and So that brings us to our first point. Today, no matter what program you're working with, whether it's Microsoft Word or Photoshop or whatever, if it has a save button, if you're working in Lightroom or something that does parametric editing, it doesn't actually change your images, so there is no save function because it's not saving anything. But if you have a program that has a save button, it has an auto save button function. It'll be in the preferences somewhere, but it's up to you to set that up and turn it on so that when your computer dies or power goes off or whatever, that you didn't lose the last 4 hours or 6 hours or 3 weeks of work. Um, and But I spent a number of years working for the Ontario Ministry of Natural Resources Wildlife Research Branch, and there was this was again back a long time ago, and there were decades, literally decades of research on individual computers and individual offices of these researchers and their staff, and almost none of it was backed up. We did think it was in the late 80s, maybe early 90s, we actually got one portable tape backup machine for the office that got trucked around to whoever wanted it. But again, it was dependent on whoever wanted to use it. And when I was I worked as a technician in the GIS lab after I graduated for a little bit. It was my job to actually write the coding for the reel-to-reel tape back that we had, and I did this some work on the backup for the GIS lab at the college. But that's enough history. Okay, so we're going to talk to some the 5 Ws, and I'll get myself out of the way here for a second. We're not going to do these in strict order, but there we go. The first question is who of the 5 Ws? This is a very quick one. The answer to that question, and unless you have a specific technical support team like Marcia does, Marcia is my wife if you don't know, then the answer to that question is you. This is all on you. And there's no, if you're looking for a step-by-step instruction as to how you should back up your computer, this is not the right place. All I'm going to do tonight is provide you with some information and as much as I can, and then it's up to you what you do with it. Um, so who? You. Now, switch my note page here. I have 3 different windows running on 2 monitors, and my notes are on paper. So who says I'm not a Renaissance man? Okay, the next question is what? Also a very simple question. And the what is anything that's only stored in one place. Um, and there's two aspects to this. And one is if you're at home, you may have a desktop computer, you may have a laptop computer, you may have a phone, and or I don't have a tablet in this room, but you may have a tablet. Keep in mind that all of these things are basically computers. We don't like to think of them as computers, maybe, but they are. And so anything that's stored only in one place needs to be backed up somewhere else. Um, and in the old days, when we bought software, whether it was your operating system, Windows or the Mac OS, or whether it was a program. We don't call them programs anymore. We call them apps. Um, but when we bought software, it came on a disk, either a floppy disk or on a CD. Nowadays, virtually all software that we buy is downloaded. So you buy the software, you get the license, you get a download file, you download it, you install it on your computer. Great. Okay. But Marcia asked me earlier tonight if I could sum up this presentation in one sentence, what would it be? And my answer to that was all computer data is ephemeral. Okay. And that's the reason that I'm here, and the reason hopefully you're here is to recognize that it can be gone poof, and if it's in one spot, then it's gone. Okay. Now, if you're traveling and you're taking pictures, you've got the images on your SD card or your XD card or whatever card you're using. Um, that's one spot. Okay. If you, like me, take the images off your SD card and put them onto your computer that you're carrying with you, or your tablet, or whatever you're carrying with you, portable hard drive device. There are devices you can buy that have a hard drive built into them, and they also have a card reader, and you can just plug your SD card into that, and it'll copy the images from the card onto that portable drive. Um, some people, especially professional photographers, will bring 1 or 2 external drives with them, and not only will they copy all their images from the camera card onto their laptop or whatever, they'll also copy it onto um, two usually different external drives, and they'll put those external drives in different suitcases. Okay, now if you're a professional photographer and traveling making pictures, then you've literally got your business on that drive, and so these are just things that you need to think about. Okay, so the next question is why? And the answer to that is, we have books that are 500 years old, um, but all computer data is ephemeral. In the days when CDs were big, you could buy archival CDs that were suggested they would last 20 years. Nobody at the time thought that CD drives may not be available in 20 years. Um, but hard drives typically last a few years depending on how often they're used. Um, and But why back up your computer? Well, because something eventually is going to go wrong. It could be hardware failure. The drive could die. Um, your computer could die, and if the computer processor dies, it may decide to take the hard drive along with it. Sometimes you can recover the data off the hard drive if the computer crashes, uh, but that's one possibility. Property damage. Your house burns down. Heaven forbid, that should never happen to you, or you get caught in a flood or whatever. But you know, something happens to your computer. Um, that's another possibility. Theft. You're working on your computer and or you're not at home, somebody breaks into your house or whatever. Again, God forbid this should ever happen to you, but it's technically a possibility. Those are all reasons to back up your data. There are less drastic reasons as well. You're going through your computer and you're in File Explorer or um, Mac Finder or whatever, and you're thinking, okay, I don't need this anymore. I don't need that anymore. I don't need that anymore. I don't need that anymore. You toss them all in the recycle bin, and then you empty the recycle bin, and the next day you're going, oops. I didn't do that, did I? Anybody here ever done that? Yeah, yeah. Okay. That's a good reason to have a backup, because then you can go back to your backup drive and recover it. Um, by the way, if your hard drive crashes on you, and that's certainly possible, um, it is often, I won't say always, but often technically possible to rebuild a hard drive, but it's very expensive. These days, you're probably looking at, I'm guessing, $1,500 and up to rebuild a hard drive. They need an actual clean room. You've seen clean rooms on television. It's the one where the people in white rooms wearing white spacesuits with absolutely no dust. Um, they will dismantle a hard drive and take the disks off and rebuild it. But it's a scary proposition, and it's expensive. It's much cheaper to simply back it up onto something else. Um, if you um, do something like reformat a drive accidentally or delete something, there is software that can help you recover deleted files. And again, that depends on what your individual case is, but that may be possible. But backups are a lot simpler. And another reason for having backups is malware, often called viruses, computer viruses. Some of them are relatively benign. Some of them steal information. Um, some of them lock up your entire computer and hold you for ransom. This is an excellent reason to have antivirus software, but it's also an excellent reason to have a backup. And before we continue on, I wanted to mention a couple of things. One is, if you now, it's been a long time since I worked on a Mac computer, but I assume they have something similar. But this here is the standard uh, flash drive, jump drive, USB drive, whatever you want to call it. There's a label on the back, which you probably can't read, but this is the recovery drive for my current computer. So if Windows crashes, which it has and likely will again at some point, I can reinstall Windows from this drive, get myself back up and running again. And or if my hard drive died tomorrow, um, I could, get a new hard drive, install it in the computer. And actually, I don't have a hard drive in here. I have an SSD, but we'll get to that. But again, I can reinstall Windows from this drive. Now, there are, I'll say three, really four types of files on your computer. One is the operating system, and that's either if you're, it's either Linux. If you're a Linux user, it's Microsoft Windows. If you're a PC person, or it's a Mac operating system. If you're an Apple person, that's one type of file. Then you have programs. Nowadays, as I say, we don't call them programs; we call them apps. But we have programs, and we also have utilities. So that's the second and third types of files. And then the fourth type is data. So those are your files, whether it's a Microsoft Word file, whether it's a PSD file, whether it's a camera raw file, whatever it is. But those are the four types of information that are, in basic terms, stored on your computer. And having backups can help you with all of those. But one thing I suggest to people, and what I do on my own computer, I'll just bring this up and show you. This is just a folder on my computer, and it's called, if you can see up here at the top, it's called the installed folder. Just gonna move myself out of the way here. Um, there we go. It's the I think it's a little bigger. Yeah, not really. Okay, back to where we were. Anyway, so this is the installed folder, and as I mentioned earlier, all of the software that we buy today is downloaded, and so every piece of software that I've installed on my computer, the installation file is in this folder. Okay. There's also one folder here called to install, which is software that I've downloaded but chosen not to install for some reason in my current setup. In addition to that, there's a file here called licenses. It's a simple text file, but it has the registration licenses for every piece of software in its folders. So I talked about the four types of files. If my hard drive was to die tomorrow, for example, what I would do, and what I have done, would be to get a new drive and install it, use the recovery drive to reinstall Windows, and then go through and run Windows Update to make sure my operating system is up to date. I would download my backup software and install all the contents of this folder from the backup drive. And then I would reinstall all of the programs. And then I would reinstall all of my data from the backup drive. And wham bam. It'll take me a couple of days, but I'm done. Okay. So that's what I do, and that's what I suggest people do, is to put all of your, because it doesn't matter to me if I'm here in Victoria or if I'm in Amsterdam or Botswana. I mean, nobody's traveling these days, but you know, I bring my backup drive with me wherever I go. And if my computer died on me, then I can rebuild it very easily. So if you don't have a system, something like this that works for you, then this is what I would suggest. Um, okay, we can get rid of that. Um, there's one other thing I wanted to mention. If you use Lightroom, and I imagine a lot of people here do, um, you can set up Lightroom to back up your catalog, your um, it's Lightroom database, and by default it will store them in the Lightroom backups folder like this. And one thing I wanted to mention is that, well, two things. One is that when you back up your Lightroom catalog, it doesn't um, back up your images. It only backs up the catalog. And the other thing to mention is that the Lightroom backup software does not delete old catalogs by default. So you can see here, I got each one of these catalogs is taking up almost a gigabyte of space, and there are catalogs going back 3 years. I actually have a bit of software on my computer that I disabled and put this up here so you could see it. But generally speaking, the software runs once a week, and it goes into this folder, and it deletes anything that's more than 2 months old. I actually don't use um, these backups. I have a plugin for Lightroom that I back up, and I don't back up to this folder. Um, so what I do is I run that plugin and I back it up to, I have a Dropbox folder. If you have a Dropbox account, um, then um, you have a folder on your computer. Let's see if I can find it here. Document, Dropbox here. Uh, so in this Dropbox folder, I have like, so these are my most recent Lightroom backups. They're zip, so they're 100 megabytes instead of a gigabyte. Um, and I don't back up to the Lightroom backups folder. I back up to this Dropbox folder so that these are the last 2 months worth of my Lightroom backups. And being in the Dropbox folder, every time I run Dropbox, it automatically synchronizes this folder with my Dropbox account so that these Lightroom catalogs are automatically backed up. Now, the Lightroom backups folder, as I say, that's the default, and there's certainly nothing wrong with it. Um, and but just be aware that if you run Lightroom backups um, and set it to back up every day or every week or whatever schedule you set it on, it will do so, but it won't delete old ones. And you can end up sometimes with 40, 50 gigabytes of old backups stored on your hard drive that you don't even know about. So just a couple of things to be aware of. Okay, so the next question is when? Well, there's a very simple answer to that question. How much can you afford to lose? So you may decide to run a computer backup every day. You may decide to run it once a week. It's entirely up to you. But we go back to the beginning, you know, what to back up, anything that's only in one place. So if you're working on some images or you're working on a book or you're working on a project for whatever, um, you know, you decide what level of risk you're willing to accept is what it comes down to. Um, and now the other part of when is, as I mentioned, um, one of the reasons to back up is to be archival. And so when you back something up, keep in mind that what you're backing it up on also has a lifespan. And for a hard drive, it could be a couple of years. For whatever, but things can go bad even if you don't use it. I mean, For example, this is an old 3.5-inch hard drive from an old desktop computer. Um, don't touch this don't touch the silver parts because you have enough static electricity on your fingers that if you're not careful you can damage it. Um, but even a drive like this, just sitting out, not connected to anything, can develop what's called bit rot because what's being stored on here is not pictures, it's not Word files or PSD files or PowerPoint files or anything like that. What's being stored on here are little electrical impulses. Now, if you were to set this down right next to your computer's subwoofer speaker, which has a very large magnet in it, then you're going to compromise your data. And even if this is just sitting on a shelf, it's technically possible that the data in here, the electrical impulses are going to start to degrade. It's called bit rot. Um, and so WIN has two tails to it. One is how often do you back up your computer, and the second one is if you're using archival things, then when was the last time you checked it to make sure it's still valid? It's just something to think about. Okay, where are we here? Yeah. Um, the I talked earlier about changing technology and changing software, and that's important. You know, 3.5-inch hard drives we can still deal with. 3.5-inch floppy drives, not so easily. I don't know of anybody who still has a floppy drive reader. Um, and the other thing is that aside from long-term archival storage, let's say you were out making pictures and you copied everything onto your micro SD card and stuck it in your shirt pocket and then stuck your shirt in the laundry. Um, SD cards are pretty robust and it may survive, but it may not. Um, so these things happen. Um, okay, so next page. Where? Bring this one up. There we go. Where to back up your stuff? Well, in general terms, there are two choices. You can back your information up locally, or you can back it up to the cloud. I remember when the cloud first became became a thing. Cloud backup is fine, and as I mentioned, I back up my Lightroom to to the cloud um, and to a Dropbox. But there's a couple of things to think about. One is data security. As a general rule, I tell people consider everything on the internet to be public, permanent, and irretrievable. Okay. There's not a computer system in the world that has not been hacked into, including the Pentagon and major corporations and places like that. Now, I'm sure people are going to be going well out of their way to capture your images of the Inner Harbor. But just, these are things you need to, if you're going to back stuff up to the cloud, you have to think about the reputation of the company who's looking after your data for you. And everybody and his dog, it seems, has cloud backup these days. If you have an Apple computer, you have iCloud. If you have a Windows computer, you have Microsoft OneDrive. There's Google Drive. There's everybody wants access to your data. Um, so again, you have to look at the integrity of the company and data security and what they're doing with that information. Are they holding it strictly for you? Um, and what security measures do they have in place? The other thing related to cloud backup is what's called throughput. Okay, so every time you download something from the internet, Even this live stream video right now, or if you download software or you check your email or you're on Twitter or Facebook, TikTok, whatever, or anytime you upload something to the internet, whether you're posting an image or whatever, all of that information is going through your internet service provider. Okay, and that's called, in general terms, that's called throughput. Now, for Marcia and I, right now, our contract, we deal with TELUS, but our contract with TELUS gives us 550 gigabytes of throughput per month. Okay, we don't do online gaming, and we don't watch a lot of stuff on Netflix, um, and so we don't use, generally speaking, even a third of that. But we have a maximum of 550 gigabytes per month. I have right now somewhere around 800 gigabytes of data, including all the different types of files, on my laptop. So if I was to decide to back up my laptop to the cloud, I've now gone in that one swell swoop, I've gone 250 gigabytes over my monthly data limit. Okay, they'll allow it, but they will charge me for it. So just be aware of that. Find out what your contract with your internet service provider is, and how much data you're using every month, and what the overage charges are. Um, it's the same thing with cell phones. We have a new contract with our cell phone company, also TELUS, that allows us 20 gigabytes of throughput a month, and we used to share 4 gigabytes on our old contract, and we never used more than half of that. But again, if you're uploading images, or you're doing something on your phone or your tablet, be aware of the fact that there is a maximum limit, and above that, they will charge you so much, depending on the amount that you're using. So you may, if you use cloud backup, you may want to use it for some things instead of everything. If you're working on an important project, or you have most valuable raw files, or something, but just be aware of that. So that's one answer to the question, where is the cloud, and the other answer is to store things locally. And to store them locally, there are a number of options. Usually these days, rotate um, localized, or not sure the word I'm looking for, related to hard drives or SSD drives. And um, this is probably a good time to talk about those two options and the differences between them and where you want to be careful. As I mentioned, uh, this is an old computer hard drive from an old desktop. This is what's considered a 3.5-inch drive, and this one had a storage capacity of 80 gigabytes. Huge. It's still a valid drive. It still works. And but nowadays, if you have a laptop, or in some cases, if you have a desktop, you're using a 2.5-inch drive, which is really about half the size of this one, in terms of physical space, and a lot thinner. Uh, Now, um, there are you can get, if you have an external drive like this one, you have a couple of ways you can deal with it. One is to use what's called a bare bones adapter, or a docking station, which is a little bit of electronics that you can see. If I hold this up here, hopefully you can see. There's a bunch of wires and things there. And the docking station basically plugs into the drive, and has something like a USB cable on the other end, and you plug that into your computer, and now you have a drive connection. And so that's a possibility. You can also get show the way. This is an external drive case for a drive like this one. And this one has an external power supply, so it comes with an adapter that plugs in the wall and a cable that plugs into the drive, and also has a USB adapter on the other end. And um, you can get a drive case like this for a 3.5-inch drive. They also make cases for 2.5-inch drives, which are much smaller. And this is this is one of my backup drives for my photographs. I keep all of my current year images stored on my computer so that I can work with them, and then all of my previous year's images are stored on this drive. And then this drive and my laptop drive are backed up onto this drive. Okay, and so you can, as I say, you can buy external hard drives like this, come with cables and stuff. Or if you have a drive that you've taken out of an old computer, you can buy just a blank case for like $30. And um, they'll you just fit your hard drive into that. Um, and if you deal with CDs or DVDs or Blu-ray, it's very hard to find a computer these days, a laptop especially. There's some desktops still have them, but it's very, very hard to find a computer these days that actually has an optical drive. You can buy something like this. This is an external Blu-ray drive, so it'll read CDs, DVDs, or Blu-rays. And again, it has a micro B cable on one end, and it just plugs in there. Sure it does. Come on, baby. There we go. Now this one also has an external power supply, but depending on how much power is provided by your computer, you may or may not need it. Um, and usually the cable that comes with a drive like this has a micro B connector on this end, and it has a standard USB-A connector like this one on the other end. However, as I mentioned, my computer doesn't have any USB-A ports, so I bought a cable for, I think it was $18, that has a USB-C connector on the other end. And now, with the USB-C connector, there's enough power coming through this cable from the computer to power this drive. Okay, so you can, if you want to, back up onto a drive like this. And CDs, DVDs, Blu-rays, they're they're fine. They don't have the storage capacity. As I say, I think the biggest 4-level Blu-ray disc is about 100 gigabytes, and 100 gigabytes in today's world is not a lot. I have a Sony A7R III camera, and each RAW file is 80 megabytes. So 100 of those is 800. Uh, is Yeah. Anyway, so it's 100 gigabytes is not a lot of space these days. So most people use external drives, and um, but there's still now the other option is an SSD, which stands for secure. Secure, I can't remember, but we call them flash drives, jump drives, things like that. You can get SSDs that fit in a case like this one, um, and in general terms, SSDs are more expensive than hard drives, and Tim asked me if I can write to that drive. I'm assuming he's asking about the Blu-ray drive, and yes, I can. If I actually have somewhere here, I have a stack of DVDs. I don't use it as a drive to write to, but yes, I could. So if you wanted to make your own your your own digital your own music CDs, you can buy an external uh, uh, drive, writable drive, and you can use it for that. So SSDs are solid state drives, and they're more expensive. They're generally more robust, and they have no moving parts. And there are two advantages to SSDs. One is, as I say, they're more robust, and the other one is that they're faster. And the reason is, if you've ever seen an old-fashioned record player, with the LP going around and around like this, and then a tone arm, that's actually playing the music that you're listening to. That's basically what a hard drive is you've got a stack of disks. They're not as big as the ones in the that old IBM 350 drive from 1956, but it's the same idea. And each disk has an arm that's lifting and putting down and either recording information or reading information from that platter. And there are a number of platters in the drive. Now, the hard drive only spins in one direction. So if it picks up a bit of information here and needs to go here, that's not a problem. But if it picks up a bit of information here and needs to go here, it can't back up. It's got to go all the way around to read it. Okay, so it's always going around and around the disk. And this old drive has a rotational speed of 4,500 rotations per minute, um, which is not that fast um, in computer terms. Thank you for the comment, by the way, Duncan. Yes, I did shave my beard about every 3 months or so. It starts to develop a mind of its own, and I have to hack it back into submission. Um, so the disadvantage of a hard drive is that it takes time to spin around and collect all the information. That drive is a very old drive. It ran at 4,500 RPM. Drives today, cheaper drives today run at 5,400 RPM. Better quality drives run at 7,200 RPM. And in the day, the really high-end drives ran at 10,000 RPM. But the idea is still the same. They're still spinning. Okay. Now, an SSD, you can think of it as like a big mailbox. You've seen those over mailboxes out on the highway or wherever with all the different little compartments, and you can pick any compartment at random. It's not limited to going this way or going this way. It can pick any one of them, and so it doesn't have that limitation in terms of rotation. So it's faster because it's random access and there are no moving parts. Okay. Now, the downside of an SSD is that you can only fill each one of those boxes so many times. Okay, you can only write to each sector so many times, and then they start to get tired. Um, Now, where this becomes important is what's known as the fill capacity of your SSD. If you have an SSD that's, say it's a terabyte drive and you've got 500 gigabytes of data on it, then you've still got 500 gigabytes of space to store to. And the computer will decide, where to put things so that things get randomized and this one little box doesn't get picked on all the time. If you've got a thousand gigabyte or a terabyte drive and you've got 950 gigabytes of stuff stored on it, now you've only got 50 gigabytes of boxes to write to. And so those 50 gigabytes of boxes are going to get written to more frequently and they're going to wear out faster. Okay, so that's, if you're using an SSD, be careful not to overfill them. That's important to remember. There is a third option. This one, see if I can get this cover off. Come on, baby. Here we go. Wrong one. Anyway, this is what the 2.5-inch drive looks like inside the case. This is not the one I was looking for, but no matter. You can get what's called a hybrid drive. And a hybrid drive looks the same like any other 2.5-inch drive, but it's a combination of a hard drive and an SSD drive. So you've got a total of, say, 500 gigabytes, and of that 500 gigabytes, let's say 400 gigabytes is stored on the hard drive, and 100 gigabytes is stored on the SSD drive. So what happens is, if you're working on a specific group of images, or you're working on a specific project, there are certain bits of information that you're reading and writing to more frequently. And so the computer will store that more frequently accessed information right now in the SSD part and only go to the hard drive part when it needs something that's not, it's like a cache file. So having access to the SSD means the hard drive doesn't have to work as hard, and it also means that you're spending less time waiting for the hard drive to spin around and access um, the information. Okay, and all right. Now, when it comes to hard drives, if you have more than one hard drive, either stored in your computer, or an external device, there are three terms you need to be familiar with. One is RAID, R-A-I-D. One is NAS, and the other one is JBOD. Okay, and these are all acronyms. I'll start with JBOD. JBOD stands for just a bunch of disks. Okay, so if you have one or more drives that have no logical connection to each other, like these, okay, these are four different cases, um, but even if they were all in one case, they have no connection to each other. So this is just a bunch of disks. Okay, if you have a desktop PC, you may have one or two or three or four hard drives in it. And if they have no logical connection to each other, then that's JBOD. Okay. RAID. No, we're not talking about the insect spray. RAID stands for randomly accessed independent disks, and there are several different types of RAID. The most common is RAID 0, RAID 1, and RAID 5. Now, RAID is not a backup system. It's a way it is a way of protecting data to some extent. Um, so if you have a RAID 0 arrangement, then you have two disks, okay, that are connected together. And every time you write a file, part of the information gets stored on one disk and part of the information gets stored on the other disk. Why you would ever do that is beyond me. I'm sure there must be some purpose for it, but don't I don't know. Okay. RAID 1, if you have two disks like this, connected in a RAID 1 configuration, when you save a file, it stores a copy of the file on this disk, and it stores the same file, the same information on this disk. So you could consider RAID 1 to be a rudimentary backup system because it's making two copies of everything. It also means you need twice as much storage space. Um, as you would otherwise. Okay. RAID 5 is a system whereby you have usually, well, it's usually four, but uh, multiple disks, and it stores part of the file information on each disk, but built into the RAID 5 system is what's called data redundancy. So that if we assume that these four disks here were all in one case in a RAID 5 configuration, and we write a file to this RAID box, then part of the information is going to be stored on one or more of these, well, more than one of these disks. Okay. What happens if this disk dies? Well, what happens is there's enough information stored on these three drives to rebuild this one. So that if you have a RAID 5 configuration and one of your disks dies, you take it out, throw it away, put in a new blank disk, and the RAID system will rebuild the information on this new disk from the other three. Okay, so now we've got data security. There's also RAID 10, and but if you want to know more about that stuff, you can look it up online. Okay, NAS stands for Network Attached Storage. So basically, it's a box, and it can have 4, 10, whatever. If you're a professional photographer like, say, Joe McNally, if you don't know Joe McNally, he's one of the preeminent photographers in the world right now. He's worked for Life magazine, National Geographic, Sports Illustrated, you name it. He's New York Times. He's shot for them. In his office, I can guarantee you, he's got terabytes and terabytes of uh, computer images. Um, and he will have a network attached storage system because, because nobody's making 50 terabytes on one drive yet, and also because there's built-in data redundancy. Okay. Um, and so you can, a network attached storage just means that it's connected to your computer through your network, usually through an Ethernet connection, um, and but it's connected to your computer through the network rather than through, excuse me, a direct USB connection or something like that. Now, if you have a network attached storage, you can and usually do have the NAS in a RAID configuration. Okay, so now we're talking about a backup system where you're backing up your information from your hard drive onto the network storage. And because of the RAID configuration, we've got data redundancy. So if one of the drives in your RAID system dies, you can take it out, toss it, put in a new drive, and everything gets written across. Okay. There are other advantages to network attached storage, like being able to access your files if you're halfway around the world. For most people, that's probably not going to be a serious consideration, so we're not going to get into that. Alan says RAID 0 is for speed. That's true. Yeah, I hadn't thought about that. Um, and but where I get hung up on RAID 0 is that if one of the disks dies, then you're basically toast. And you know, because an NAS system is connected through your network rather than directly to your computer, I would not recommend it for files that you're actively working on because it's going to take a long time, especially if you're dealing with big files. So it's great for archiving stuff, and but it's not so good for active files. Okay, where are we? Yeah, one other thing to think about if you're backing stuff up locally is, you know, if you have your everything on your computer backed up onto an external drive and your computer crashes, great. You've got a backup drive that will you can use to rebuild your system. If your house burns down, not so good. Now, you can buy fireproof boxes, and I'm not sure how well they work. I mean, they're designed to keep paper from incinerating. Uh, I don't know that anybody's ever actually tested to see if a hard drive would survive a house fire in a fireproof box. If that's a big concern for you, then set up. And if you have a friend who has a computer, you might want to set up a system with them so they keep a copy of your backup at their house and you keep a copy of their backup at your house. Think of it as a localized cloud. It's something to think about, and you have to decide for yourself what level of risk you're willing to work on or work with. um, okay, so that covers the where. And now we're down to the last question, which is how. Okay, there are a number of different components to this, and there are essentially three, actually five, but we'll say three different backup strategies. Uh, so we have full backup, and a full backup backs up everything from one place onto another place. Um, and I remember back in the early 90s, a friend of mine and I in Ontario uh, finished a project for Parks Canada, Western Canada Parks in Calgary on forest fire management in Western Canada Parks. So we created this Photoshop program, but then we had to get it from Ontario to Alberta. And this was the early 90s. So internet wasn't really a thing then. It took 56 3.5-inch floppy drives in a box to get that information from A to B. Um, anyway, yeah. Uh, but so anyway, a full backup is when you copy everything from one place to another place, depending on the size of your source and the size of your destination. It may be one for one. If you're backing up your computer onto CDs, and CDs hold 780 megabytes, then you may need a bunch of them, like those 56 floppy drives, in order to get all of the information copied over. Um, so that's a full backup. But you don't necessarily have to do a full backup every time you back up. There are two ways you can back up just some of your stuff. Well, three ways, obviously. One is to simply select, um, only a portion of your information and back that up manually. Um, but we have what's known as incremental backup, and we have what's known as differential backup. And so um, they're different in that an incremental backup backs up everything that was changed from the last incremental backup. Differential backup everything that was changed from the last full backup. Okay, so the difference is mainly in, well, incremental backup takes less time, and each incremental backup takes less time and is smaller, but restoring takes longer because let's say um, you have a full backup, and then the next day you've worked on one file, and you do an incremental backup, so it backs up that one file. The next day you back up a different file, Okay, so now you've got two incremental backups, and they've got two different files on them. And the third day, you back up two files, and so now we've got three backups with four files on them. Okay, each one of those is different. So when you restore, you've got to restore the full backup, and then you've got to restore each of the incremental backups because each one of them has different information. So differential backup, you back up everything. Day one, you change one file, it backs that up. Day two, you change another file. The differential backup backs up this file plus this file. Day three, you change two files, so now you've got four files. Okay, so the incremental backup on day three backs up this file and these two files. So your day three incremental backup's got four files on it. Your your day three differential backup has four files on it. Your day three incremental backup only has the two files from that day. So with a differential backup, if you need to restore, you restore your full backup and then you restore your latest differential backup because it has everything that's changed since this one. Hope that makes sense. Okay. When you back up a file using whatever backup software you're using, basically it says a little check mark that says this file has been backed up. This file has been backed up. This file has been backed up. When you change something, and you can decide, depending on the software you're using, what change means, um, then it basically unchecks that box. And so it knows that this file has changed. So personally, I use differential backup rather than incremental backup because that way when I restore, I only have to restore my full backup and my differential backup. Okay. Um, and if you're using an Apple computer, you have Apple Time Machine. The default is, and I don't know if you can change it. I don't know enough about Apple, but Apple Time Machine is an incremental backup. So it's quick, it's easy. You don't have to think about it. All you have to do is set it up, and it does that for you. But restoration is going to take longer because it's got to go through every one of those incremental backups and back them up and restore them individually. I mean, uh, Windows has a backup as well, a default Windows backup. I believe it works on the same principle. I never used it, so I can't tell you. Okay, just want to quickly mention, um, I talked about the three and the five ways of backing up. The fourth um, is what's called a snapshot or a system image. Now, when you back up, if you use backup software to do a full backup of your computer, there are some files that will not get backed up. And the reason is those are active Windows files that it protects. It won't allow you access to them, and it won't allow you to back them up if you're using third-party backup software. Um, and um, if your computer crashes, you're going to have to reinstall Windows anyway, so that's not a serious issue. But a snapshot or a system image is a complete, it's like taking a photograph of all of the information on that drive. So if you're wanting to move everything from one computer to another computer, you could use a system image to do that, and it would take everything exactly. Okay, I probably wouldn't do that. I would probably um, go the route of setting up the operating system, reinstalling the programs, and checking for updates, and then installing the data. That's the system I use. But just so you understand what a snapshot or a system image is, as opposed to a backup. Now, The fifth option of and when it comes to backup, is called mirroring. Okay. When you back up from A to B, whatever your source and destination are, um, you're copying stuff from A to B. Okay. Now, if you're backing up, the software is assuming that you want to copy everything from here to here. But there are options to say, what if something is here but not here? Okay, well, we copy it over. That's a given. That's a backup. But what if we have something that's here but not here? Okay, so you go out and you take um, a bunch of images, say 200 on a day, put them all on your hard drive, you back them up. You go through those 200 images and you decide there's 30 that you're going to keep. Okay, so you delete the other 170. They're no longer on your hard drive, but they are on your backup drive. Okay, now if you set up a mirror as opposed to a backup, when you run the software, it's going to look at this, it's going to look at this and go, huh, there's 170 images or files on here that aren't on here. Should I delete these 170 files? That's a mirror. That's something you want to be careful with. Okay. You may decide to do a full backup once a week or once a month, for example, where you copy everything from your hard drive onto your backup drive. And then as you go through and delete images that you no longer want on your hard drive, you may decide to run a differential mirror so that it removes all of that junk from your backup drive as well. Or the other option is just to buy a big enough backup drive that you don't have to worry about running out of space and you just keep all that junk. So those are considerations you have to think about, but just be aware of it, that when you're setting up your backup, it's going to ask you, if it's on here but not on here, I copy it over. Fine. If it's on here but it's not on here, do I delete this? Okay. Because those, again, once it's gone, it's gone. There are undelete software and things like that, but just something to be aware of. There's one other thing, the next thing to think about, and this doesn't relate to Mac users, so you can take a short break, but it does relate to Windows users. Um, Back in the early days of computers, um, they didn't have hard drives. They only had one or later two floppy drives. Um, and the standard back then was you put your program disk, well, you had to start with your boot disk. So you put your boot disk in, and that would get the computer up and running. Excuse me. And then you would take your boot disk out and put your program disk in, and then you could start the program that you were using. And then if you had only one floppy drive in your computer and you wanted to save a file, you had to take the program disk out and put the data disk in. I'm serious. And um, when we got to two floppy drives, then we had a program disk and a data disk. So you still had to put your boot disk in, but you could take that out, put the program disk in, and then write to the data disk. Um, in those days, the first disk was called the A drive, obviously, and the second disk was called the B drive. When we got hard drives, um, the hard drive was called C. So if you're ever wondering why your hard drive on your Windows computer is called the C drive, that's why. A and B were reserved for floppy drives that no longer exist. Now, if you're working in Windows and you plug in another drive, whether it's one of these um, or one of these, or even a CD or a DVD. By default, the first drive you plug in is going to be called D. The next drive you plug in is going to be called E, and then F, and well, you get the idea. However, be careful because that drive letter defaults to the first drive you plug in. Okay, so if you tell the software to back up from your C drive to your D drive, you only got that one drive plugged in, yeah, that's fine. But if you tell the computer to back up from your D drive to your E drive, but you have them reversed, then you could be letting yourself into all kinds of trouble, especially if you're mirroring and removing information or overwriting information that you didn't want to do. There is a way around that in Windows, and that is to assign a specific drive letter to each drive. Okay, so this drive, you can't see it, but it says pictures on it. As I mentioned, this is my archive drive of my images. So this is everything from 2020 back to wherever, all of my older digital images. So because it's a pictures drive, I call it the P drive. P is in Papa or Peter. Okay. Um, this drive is my backup drive. And I can't call it B. Windows won't let me, but it's a Seagate drive, so I call it the S drive. Okay. So now when I back up my pictures onto my backup hard drive, I'm backing from the P drive onto the S drive. And those letters will be consistent no matter when I plug them or unplug them from my computer. They're always the same. Okay. There is some software, it's very rare, but there is some software that will assign an arbitrary designation to a drive, like K or something like that. I'm not sure why they do that, but that doesn't happen very often. And so just, again, it's something to be aware of in terms of assigning specific drive letters to your drives. When Mac computers don't use drive letters, they use drive names. You can call these, this is in Windows, this is the pictures drive, but Windows doesn't recognize it as the pictures drive. It recognizes it as the P drive. This one doesn't matter. So I just leave it as whatever, D or E. Same thing with flash drives. Most flash drives are just used for temporary storage, and so I don't assign them drive letters. Too many things to keep track of. Okay, the other thing to be aware of is when it comes to drives, and again, I'm not exactly sure how this works on Mac, but on Windows, you can create what are called partitions on your drives. So you have a physical drive, let's call it the D drive, and but I can logically, so not physically, but logically break that drive up into, say, two components. So now I have a D drive and an E drive. Okay, and you will often see this on the camera card in your camera, where it will create a partition within the SD card itself to keep track of system information that it needs to know that you don't. So you have so much space on your SD card for storing your images, but there's also another partition, excuse me, that is used to store system information. So just be aware of that. Again, when it comes to to naming drives and dealing with drive letters and things like that. Um, and yeah. So scheduling, you can set this up to work automatically. If you're using a laptop or a tablet or a phone, you may have to make sure that it's turned on. Depending on the system that you have, you may have to physically connect the drive to the computer in order to back it up. Or if you're using a network system, you may be able to back it up through Wi-Fi. But again, those are options. And we're down to our last couple of bits here. One is with your backup software, there may or may not be an option to compress the data and or encrypt the data as it's backed up. Okay. If you're working for Microsoft's security team or you're working for the Canadian military, encryption may be important. But in my estimation, for 99.9% of the people, do not encrypt it and do not compress it, because anytime you do that, you've got to unencrypt it and uncompress it, and you're just opening yourself up for a world of hurt. And the last thing is how to verify, as I know Linda asked this question, how to verify that what you've backed up is actually there. Well, if you haven't compressed it, then you have the same file stored on your external drive or CD or wherever you've put it that you have on your hard drive. So you can just go into Mac Finder or go into Windows File Explorer or whatever and go to that drive and click on it and open the file up and see. There is also usually an option, depending on your software, to verify when copying. And that takes longer, but it can go through and copy the file from A to B, or C to D in this case, or wherever. And then once it's copied, it goes back and says, yeah, okay, that's good, check, next. And then, okay, so you can do that, but it will take longer. And that's pretty much it. So that's the how, and thank you for coming. I'm just going to move myself out of the way here for a moment. There we go. I figured, being the photo meetup group, we should have at least one picture. And this is an image, actually a series of images that Marcia took a few years ago down in South Carolina. And I joined them up for her and pushed it around a little bit. But so that's all I got. So thank you all for being here. And if you have any questions, you can either post a comment on the photo meetup page, or you can message me through the group. And if I don't know the answer, I'll make something up, and you won't know the difference anyway. So thank you for coming out. And I guess that's about it. Have a good night, folks.